In this video, we are going to simplify some expressions involving imaginary numbers. Now, when you see a negative under a radical, you know it's going to be I, because the square root of negative 1 by definition equals I, and when you have the square root of negative 81, that's the same thing as having the square root of negative 1 times 81. So, you don't really do all that though. You just look at that negative and you bring it outside as an I. So that means you have I radical 81. Now we know the square root of 81 is 9, and the I goes on the right. So the answer would be 9I. Now number 10 is slightly more complicated than that. Let me refer you to the chart to help us out. Now, the four basic forms of I. You got I, you could have I squared, you can have I to the third power, and you have I to the fourth power. After that, it begins to repeat. Now, I cannot be simplified, so I is just I. But I squared is equal to negative 1. So that's a fact that you basically memorize. I'll come back to I to the third power. So we have I, we have negative 1. Now I to the fourth power is going to be positive 1. Basically these two go together. If I squared is negative 1, then of course I to the fourth power is I squared squared, right? Because that would make 4. You know what I mean? But I squared squared would be negative 1 squared, which would be positive 1. So if you know the relationship between these two, then if you know I squared is negative 1, if you square that, you're going to get positive 1. So that helps me remember because they go together. Anyway, so look, I have 1, negative 1, I, and guess what? Negative I. It's the only thing that's left. Because there's one of each. There's a positive I and a negative I, a positive 1 and a negative 1. Some students like to think to themselves, hey look, the middle two are negative and the outer two are positive. That helps some students. So if that helps you, use it. Okay, one more thing. Another way to look at the I to the third power is I to the third power is I squared times I. And if you know I squared is negative 1, then that's negative 1 times I, or negative I. Anyway, you've got that. What else? Now, this column is for money. Now, this is like a trick that I'm teaching you. Think about quarters. So each I is like a quarter for this trick. So 1 I is like 1 quarter, so that's 25 cents. Alright, 2 I's, that's 2 quarters, so that would be 50 cents. 3 I's would be 3 quarters, so that would be 75 cents. And 4 I's would be 4 quarters, which would be $1. Okay, so if I give you any power of I, you can use this chart to help you figure out what it is. For example, if I say I to the 25th power, the way you can quickly evaluate that is divide by 4. Okay, we're always dividing by 4 because there are 4 possibilities. And it just helps you to figure out which one of the 4 possibilities you fall into. So 25 divided by 4, for example, 25 divided by 4 would be 6.25. It's the decimal part that's important. Okay, the 0.25 tells us that we're in situation number 1, and the answer would be I. Okay, now all that was background to enable us to do this problem. So it's I to the 18th power. So we will do 18 divided by 4. Okay, that gives us 4.5. That 0.5 is the part that we need. All right, the 0.5 tells us that we're in the second situation, and the answer is -1. All right, and that's how you do that. So, number 11. Okay, the best way to think about this is anything squared is that thing times itself. You know what I mean? Q squared means Q times Q, right? So if I have these parentheses squared, that means parentheses times parentheses. So in other words, 4i radical 3 times 4i radical 3. Now, I'm not going to like FOIL this or anything because this is not a binomial. All right, I'm just going to multiply the terms that can be multiplied. So 4 times 4 is 16. I times I is I squared. And radical 3 times radical 3 is 3. Wait a minute, you say. Where's this 3 coming from? Radical 3 times radical 3. Well, okay, I'm glad you asked that. So the thing is, radical 3, whoa, that was cool. Oh, and now it's gone. All right, radical 3 times radical 3 is radical 9, right? Because 3 times 3 is 9. Radical 3 times radical 3 is radical 9. But the square root of 9 is 3. So that always works, right? If I have radical 5 times radical 5, that would be radical 25, but the square root of 25 is 5. So anytime you have a radical times itself, you can kind of skip this middle step and go straight to here. So if I said, what's radical 113 times radical 113? Now, I don't know what 113 times 113 is, but I know that the answer is going to be 113, whatever this is. Okay, so that's what I did. Radical 3 times radical 3 is 3. So let's just simplify this. First of all, 16 times 3 is 48. All right, 16 times 3 is 48. And I squared is -1. All right, you just have to memorize that. So that makes this a -48. That's it, simple. All right, let's go back to number 12. Now, the only thing wrong with this is we're not allowed to have I in the denominator. And the quickest way to get rid of I in the denominator on this problem is simply to multiply the numerator and denominator by I. It's the quickest thing to do. So that gives me 7i squared in the denominator. So I have 4i over 7i squared. So that's 4i over, well, I squared is -1, so that just makes this -7. So that's it. All right. So basically, look at it again. All that happened is we had 4 over 7i. All we really did was the I moved from the denominator to the numerator, and then it became negative. Okay, so that's like a shortcut for you. So if I had 5 over -12, I'm sorry, well, I could do that too. And I had the I in the denominator, this would just be 5 over 12 with the I in the numerator. You could just move the I and change the sign. Okay, so that's a shortcut. All right, anyway, back to business. Number 13. For some reason, students have a really hard time with this problem. I've explained it like over and over and over again to the same kids. And when it comes time for the test or the retest or the practice test, they still get it wrong. I'm not sure why it's so hard. But here's what you do. We're not allowed to have i's in the denominator. To get rid of the i's in the denominator, we will multiply by the conjugate. 2 plus 3i, the conjugate is 2 minus 3i. So that's what we have to multiply by. We have to do it in the top and the bottom, so I need to multiply the numerator by 2 minus 3i as well. Okay, so in the numerator, I'm just going to wind up doing the distributive property. So 6i times 2, that's going to be 12i squared. I mean, no, not I squared. Just 12i. And 6i times 3i is going to be 18i squared. Alright, now down here in the denominator, I've got to do some double distributive property. So, for example, I'm going to multiply 2 times everything. So 2 times 2 is 4. 2 times negative 3i is negative 6i. Alright, and now I need to distribute the 3i like this. 3i times 2 is positive 6i. 3i times negative 3i is negative 9i squared. Okay, now these are going to cancel each other out. And also, so I've got 4, alright, but I squared is negative 1. So this is negative 9 times negative 1. A negative times negative is a positive, so this is really positive 9. With no I anywhere. So this is going to become, alright, so similarly, this I squared is also negative 1. Negative times negative is a positive. So this is going to be 12i plus 18 over, and 4 plus 9 is 13. Okay, so now I'm going to do two things. The I term is supposed to go second. So I'm going to wind up switching these terms of the numerator around. So I'm going to write 18 plus 12i in that order. Second, instead of writing one big fraction and putting a 13 under it, I'm going to take the 13 and write it separately under each side, because we're supposed to write it in the form a plus bi. Alright, not like one big fraction. Okay, so that's what I'm going to do. I will take this 13 and write it twice. And that's my answer. Alright, better practice that one, you guys. You guys really have trouble with it. Alright, number 14 is super easy. Especially since this one is addition. I don't even have to distribute the negative sign. Like if this were minus right here, I would have to distribute the minus sign. But it's a plus. So really the parentheses aren't doing anything. So I could ignore them. So this is like having 2 plus 3i plus negative 1 minus 9i. I just took away the parentheses. There's nothing in front here to distribute. This is only a positive, alright? Distributing a positive doesn't change anything, leaves everything exactly the same. So this is what I have. Now, 2 and negative 1 make 1. And now, positive 3i and negative 9i make negative 6i. So that's the answer, just combining like terms, that's it. Alright, look at number 15. What is the imaginary part of this? Well, this is the real part, and this is the imaginary part. Alright, you can tell because there's an I here, and I stands for imaginary. So the imaginary part is 15i. Alright, how about number 16? Well, first of all, let's put these together. Although I don't really have to. There's two ways to do this. I could do it the way it is, because I to the 4th power we've memorized that that's 1. I to the second power, we've memorized that that is negative 1. 1 times negative 1 is negative 1. So that means the answer is going to be D. Alright, so that was pretty simple. In general, if I give you two I parts like this, two factors, you would want to go ahead and multiply these together by adding the power. So this would be the same thing as I to the 6th power. Now if you want to use my little shortcut here, okay, remember this? So if I want to do I to the 6th power, then I can do 6 divided by 4, yeah? So 6 divided by 4 gives me 1.5. The 0.5 tells me that it's going to be negative 1. Okay, either way. Now, alright, so this will be the last problem for this video. So this one takes a slightly bit more thought, but here we go. Look, we're dividing and such here, so understand this. If I had, say if I had x to the, let's say 7th power, divided by x to the 3rd power. That would be x to the 4th power. Now the reason why is because x to the 7th power would be x times x times x let's see, 1, 2, 3, 4, 5, 6, 7. Yeah. Over x to the 3rd power. So the thing is, the 3 x's in the bottom would cancel out 3 of the x's in the top. And that leaves 4 x's. Alright, that's why it's x to the 4th power. Now, a shortcut is to look at it and go 7 minus 3 is 4, but this is why we're subtracting, is because really we're canceling things out. But subtraction, 7 minus 3. So that's key. So have that in your brain that you can subtract these. That will help you for when it's a fraction later. So if I have x to the 3/4 power over x to the 2/3 power, then that would be the same thing as x to the 3/4 minus 2/3 power. I could subtract just like I did before, even though I can't do it in my head. Now I could do this out the long way, but 3/4 minus 2/3, I can use my calculator. 3/4 minus 2/3. Alright, that's 1/12. Okay, so that would be the answer. So why am I mentioning this now? Because the square root of x is the same thing as x to the 1/2 power. Alright, that's something you should have memorized. So I have square root of x is x to the 1/2 power over x to the 3rd power. So like I said, you can subtract. You can go x to the 1/2 minus 3 power. 1/2 minus 3. Now I can do this out by hand, or I can use my calculator and do 1/2 minus 3. Alright, that comes out to be negative 5 over 2. Okay, negative 5/2. Now we have learned that when we have a negative exponent, it's the same thing as 1 over x to the, and then you write the power as positive. So far we've got this. Now, we didn't start off with fractional powers. We started off with radicals. So for our final answer, we need to change this back into radicals again. So I'm still going to leave it as 1 over, but remember that when you're looking at a fractional power, the numerator is the power and the denominator is the root. Power over root. So I'm going to do the second root. Okay, and you don't put the little 2 there. It's understood. Okay, so I'm just going to erase that 2 now. All right, it's the second root of x, and then the fifth power. Now it doesn't matter whether you put the fifth power on the outside like this, or whether you put the fifth power on the inside like this. Those would have been equivalent. So let's see what we've got. All right, see that 1 over x to the fifth power? And we have 1 over x to the fifth power. That means the answer is A.